Hi! So this is my Minimalist entry for the 2018 Flash and Light Prize. So when I first heard about this year's contest, I thought, well, maybe I'd make something that works by dividing down the power line frequency with, say, Decatron counting tubes. But then I saw that the 100th idiot had already made a submission using ring counters, and I thought, to divide down the power line frequency, and I thought, well, you know, that's really not that different, and even his design is fairly complex, so I thought, well, maybe I can build something much simpler and more elegant. So this is what I came up with. So the way this works is basically we have a power supply, we have a relaxation oscillator using this neon lamp, and then we have a two-stage ring counter with these two. And to go into exactly how that works, what happens is the power line voltage comes in here, is rectified by this diode, which is here, charges this filter capacitor, which is here, and then I have, for safety, a discharge resistor here. Then we get to the interesting part. So normally, one of these two lights is lit, and that drags this voltage here down to around 70 volts for these particular neon lamps. So that means if there's 170 volts here, there's about 1 milliamp flowing through this resistor. At the same time, the voltage on this lamp starts out low, but there's a trickle of current flowing through this 7 megohm resistor, which is made of these 1 megohm resistors in series. And that causes this voltage to gradually rise across this neon lamp. Now, eventually it hits the striking voltage, which is the point at which it starts to conduct, and you see it flash. And when that happens, all of a sudden, a bunch of current starts flowing through this capacitor, and it drags this voltage here down with it. So that causes the 1 milliamp that's flowing through here to instead divert this way. So what that means is that whichever one of these lights that was lit is suddenly off. So, okay, so then how does that make these flash? Well, normally there's a milliamp flowing through here. Say that this light is lit, so the current's flowing through here, through this 6.8K resistor. So that causes about 7 volts to be across this resistor. This point is about 7 volts above ground. What that does is that causes this capacitor here to charge up to about 7 volts. Now, when current suddenly stops flowing through here, then these points go down to ground, and this capacitor stays charged. So this point is actually at approximately -7 volts. And what that means is that when this voltage starts to recover, once this capacitor is charged up, this voltage is rising again, and the voltage across here is about 7 volts higher than the voltage across here. This is approximately ground still. So that means that this one's going to fire first, and then the current is going to stay flowing through this one. And then, as soon as this conducts again, it'll slip back. So twice a second, this conducts, so that's got a rate of about 2 hertz, and that causes this to alternate every half a second. So each one of these has a frequency of 1 hertz with a 50% duty cycle. Now this doesn't give a particularly accurate timing. The speed of this oscillator depends a lot on the power line voltage, so I just changed this resistance, how many 1 megohm resistors I had in series, until it was approximately right. But this is, I think, a nice, simple, and elegant circuit that uses only neon bulbs, diodes, capacitors, and resistors to flash a neon lamp, or 2 neon lamps, at 1 hertz. Thanks!